If you have an Android phone, chances are you're using an app built in Kotlin every day. Hi, my name is Stepan Fordey. I'm a full-stack engineer at Meta working on Ads Manager, one of the world's biggest ads platforms. Kotlin became a language of choice in many apps at Meta since 2021. Before Kotlin, Java was the primary language to implement Android apps at Meta. Having adopted Kotlin, we noticed almost 12% increase in developer efficiency. That means that on the 8-week-long project, you can save the entire week of work. So that's huge. And this was one of the major reasons why Meta is pushing for adopting Kotlin so much. Kotlin adoption was gradual at first. A lot of different changes needed to be made for the infrastructure to be able to start writing and shipping code in Kotlin. On top of that, we wanted to make sure that we don't regress any quality or time to load for the apps used by billions of users around the world. So we went with this careful and tested how the Kotlin code performed. And as our confidence grew, we started to increase the adoption across different apps in our codebase. The project to migrate all Java code to Kotlin is definitely ongoing. Our first goal there was to stop adding new Java code, at least. So we set the goal of having 0 new Java libraries in our codebase and transition to writing all of the new code in Kotlin. Instagram has become the first Meta app to set the goal to write all of the new code in Kotlin. We called it being Kotlin first. Instagram backend is implemented in Python, and Instagram frontend was implemented in Java for Android. So when we rolled out Kotlin, we tried to compare Kotlin performance and developer efficiency across Kotlin and Java as a benchmark. Teams who adopted Kotlin reported being more productive with less boilerplate code to write, like, for example, the data models or different edge cases. Teams have also reported less bugs because it became safer to introduce changes when you don't need to worry about as much code as with Java. I hope this video helped you understand how Kotlin is used at Meta and how it makes our developers' lives easier and more enjoyable. And I hope you also have fun learning Kotlin, one of the most modern languages out there.
Mobile technology continues to expand its application over a wide range of devices. You've possibly interacted with such technology on many different devices, including phones, wearables, TVs, and other household appliances, as well as dedicated automobile offerings. Android is one of the world's most popular mobile operating systems. There are many millions of users on this platform, and it continues to grow its share of the market. There are choices of language when coding, and Kotlin is one of the most popular languages used on the Android platform. Kotlin is a great choice when building an Android app, and it will allow you to create code that exploits many Android features. Just as you can choose which language to program in, you can also choose which mobile platform to code for. Because Android is such a popular and powerful platform, it is integral to mobile software development. That means it is important for you, as a new developer, to be able to program for Android devices. You can do that using Kotlin. And the purpose of this course is to help you begin your Kotlin development. You'll start in this module by considering what you hope to learn in this course and reviewing the course syllabus, checking out how a typical mobile developer uses Kotlin, and getting some pointers on how to be successful in your learning in this course. After that, you'll move on to begin the coding part of your learning by exploring core Kotlin concepts such as basic types and variables, conditions, and loops. In the next module, you'll enrich that programming knowledge. You'll learn more about Kotlin, and you'll discover how to use its functions, classes, and objects, and its interfaces and inheritance. Then you will be around the halfway mark, so continue straight on and explore advanced classes and objects, including special kinds of classes, nullability, and collections. Finally, you will have an opportunity to put your new skills to the test by taking the graded assessment, completing the bank account practical project, and using the self-review. This course is part of a program of courses leading you towards professional certification and a career in Android development. Be sure to also check out the other courses in this learning path. In summary, this course provides you with an introduction to using the Kotlin language to create Android apps. You may have encountered new technical words and terminology in this video. Don't worry if you don't fully understand all these terms right now. Everything you need will be covered during your learning.
Did you know that Kotlin was fully Java compatible? That means you can still use all of your favorite Java libraries when you write your code in Kotlin. Hi, my name is Stepan Fordey. I'm a full-stack engineer at Meta, working on Ads Manager, one of the biggest ads platforms. In this video, I hope you will learn about what a developer career can look like for a Kotlin engineer and why Kotlin is so popular these days. So Kotlin was introduced in 2016. That's when I tried it first. Kotlin came as an improvement over Java, when Java was one of the most popular languages out there and the language to write code on Android. Because there was so much code on Android already, Kotlin came fully Java compatible. It's also a JVM language, so that you can still reuse all of the frameworks and classes that you have in Java, and you can start writing Kotlin code incrementally, and you don't need to rewrite and re-implement all of your app from scratch. So Kotlin came as an improvement over Java. Sometimes Java feels very verbose, and when you write code in it, you feel like some of that can be automated. That's pretty much how Kotlin won the hearts of Java engineers. With Kotlin, you write less code, so you move faster, and you also don't need to worry about the edge cases as much. So you produce higher quality, more stable code at a faster speed. So what's not to like about Kotlin? Adoption of Kotlin is very challenging. There is so much code written in Java when it was the only language to write Android applications. Figuring out how you want to structure your code, how you want to migrate gradually, is probably one of the biggest challenges that an existing Android product faces. It takes a lot of planning and careful structuring of different code dependencies across the layers so that you can truly take advantage of these multi-platform capabilities and reuse business logic across all of these multiple platforms. And even then, it's still not possible to do everything. Sometimes you just have to write a native module in Objective-C and use that code in Kotlin on iOS, or write something in C++ even. So even though Kotlin allows you to do multi-platform development, there is still some need to do native engineering across the board. Having said that, I'm so excited to see what comes next for the multi-platform engineering. The idea that you can just learn one language and write so many things on so many platforms is amazing. Kotlin isn't just used for Android development. You can write multi-platform code with Kotlin as well, using the Kotlin multi-platform framework. This means that you can also write iOS applications. You can also use Kotlin on the backend, where Java was and still is one of the most popular choices. You can even write your website with Kotlin by automatically translating it to JavaScript. Working in large versus small company makes some difference in how your role as a Kotlin engineer looks like. In a small company, you'll need to think how to apply Kotlin across all of the app, across all of these layers. And if you're using Kotlin for multi-platform development, you will participate a lot in figuring out what's possible and what's not across these platforms. So you'll need to make a lot of mistakes and learn from that to understand all of these limitations. In a large company, there is a big chance that somebody has already figured this out, and you just need to follow the paths that architects provided. As a trade-off, you will focus more on applying Kotlin to your product, and you will migrate the codebase faster. You'll probably have a much cleaner codebase, and you will have somebody who can help and support you working in a large community of other Kotlin engineers. Even if you just use Kotlin for Android engineering, it still helps you a lot because you can produce higher quality code, more stable code faster when you write in Kotlin. So it pays to take time and learn some basic concepts. And when you think about it, it's not that much different from other major languages, but comes with a lot of improvements. Kotlin is one of the most recent languages and one of the modern ones out there. So I hope you enjoy your path of learning this.
As an aspiring developer, it's important to know exactly what a program is and what it does. Programming is a fascinating skill that allows you to talk to computers. Let's explore how it works. In this video, you will learn how to interpret the current role of programming in a changing world, recognize that a program is simply a set of instructions created using a programming language that a computer must follow, and explain how a programming language like Kotlin helps us tell a computer what to do. Meet Jane. It's Jane's day off from work, and she has 3 things on her to-do list: buy groceries, track her heart rate while exercising, and buy flowers for her friend. At the grocery store, the cashier needs to use the barcode reader to get the information and prices for each of the products Jane wants to buy. The cash register adds up these prices and calculates tax and any possible discounts. Jane pays with a credit card, and then the register prints out all the relevant information. Later in the day, Jane uses her smartwatch to track her heart rate while exercising. The smartwatch is synced to her personal profile on a social fitness app. She chooses what information about her activity she discloses, and she also gets to choose who sees this information. Lastly, after finishing her exercise, Jane orders flowers online for a friend. For many people, just like Jane, their daily activities are intertwined with computers and computer programs. But what exactly are programs, and how do computers understand them? A computer program is just a series of instructions based on some rules. These instructions tell a computer what to do under some specific circumstances, and they are written to perform a specific set of tasks. For example, when Jane was buying groceries, a program took the input received from the barcode scanner and converted it to a price for each item. The cash register program instructed the printer to take these prices, together with some other calculations, and print them out. When Jane was paying with her credit card, the point-of-sale machine contacted another program at another location. This program took care of all the bank processing and updated the balance on Jane's account. Yet more programs were involved when her smartwatch tracked her heart rate. Finally, for Jane to be able to order flowers online for a friend, a lot of other programs on many different machines were involved. These might include satellites or some other telecommunication computer programs. All of these programs are called software, and they are, in one way or another, running on physical machines which are referred to as hardware. Programming is simply the process of writing the steps a computer needs to take to complete a certain task. To program these instructions, we use programming languages. A programming language is a little like a bridge that we use to facilitate communication between computers and people. For a computer to understand a programming language, it needs to save it somewhere in its random access memory, RAM, or on a disk. Programming languages are saved in binary code, which represents data using a series of zeros and ones. Binary code is a representation of machine language that a computer can understand. All of the zeros and ones in binary language represent the state of electrical switches. Either a switch is turned on or it's turned off. Finally, a computer's central processing unit, or CPU, can comprehend these binary electrical signals and update itself accordingly. The machine language, with its series of zeros and ones, is known as a low-level language because it's closer to being understood by a computer's CPU. There are also high-level languages, such as Kotlin, that need to be interpreted. That is, converted to binary code that a CPU will be able to work with. So you might think of Kotlin or any other high-level language as a tool that helps you to communicate with a CPU. As you saw with Jane's example, computer programs are everywhere. So programming is a very exciting field that touches almost all aspects of the modern world. And now you are on your way to becoming a part of that world as a developer. You may have heard of variables, values, and types that are used in programming. These are three very important aspects when programming in Kotlin. Let's explore what you will learn about these in the next few minutes. At the end of this video, you will be able to explain what a value and a value type is. You will be able to identify the string, int, double, and boolean types of values. And you will also be able to explain what a variable is, as well as the difference between a val and a var variable. You may remember that you previously implemented a short program in Kotlin. Now you may be wondering what the words main, println, and hello world mean. Main is a starting point for your program, and println is a function call that prints text on the screen. You will explore these two functions in greater depth at a later stage. In this video, I will concentrate on hello world. Hello world is a value that represents text. The quotation marks are very important as the content inside of them is not code, but a text value. So when I call println open parentheses hello world end parentheses, the text hello world will be printed. Besides hello world, there are also other values you can print, such as a number with a decimal part, or a special value like true or false. You have now explored the different kinds of values and the output produced from using those values. So, how are these values grouped? Values are grouped into types. A string, for example, is the value type for all text values, and developers often refer to all text as strings. Strings are very useful as you can use them to store items such as a username or text, indicating that a user is a new user. In programming, you group numbers into fractional or decimal point numbers and integers, and each value is a very precise type. An integer, or int, is a data type that represents real numbers. You can also use integers to represent a user's age, or for example, the number of new messages you receive on your cell phone. If you have numbers with a decimal part, it's called a double, and this can be used to represent items that contain fractions, such as a user's height or weight. Now let's explore the next type of value, called a boolean. A boolean is a true or false value. You could use this type of value to represent, for example, if a user agreed to a website's cookie policy, or if an account is a valid one or not. Now that you are familiar with the various values and their types that exist in programming, let's explore what variables are. You define a variable to store values. This means that you can, for instance, define a variable called name and assign this variable to a current username. Thanks to the capability of a variable, you do not need to repeat the value of the variable called name in the code, as you can use the variable to reference its value. Let's explore how this works in practice by using the variables name and age. You can do this by starting with the val keyword, which is a short form of the word value, then specifying a value for name, in this case Leonardo, followed by the equal symbol, and finally specifying this variable's value. The first variable, called name, points to the string value, which is Leonardo. The second variable, named age, points to the int value 42. This means that when you define a variable, you can use its name to access the value. So, if you print name, Leonardo prints as a result. You can follow the same process for age, and the age of the user displays. Did you know that you can use a variable multiple times? Isn't that great news? Note that when you specify a variable by using the val keyword, you cannot change its value. So how do you solve this? You can use the var keyword instead, and you can assign a new value to this variable, which, in this case, is Michelangelo. Var is short for variable. Var variables can be assigned new values whenever you like. As in the case of values, variables also have types that you can specify explicitly. To do this, you add a colon and type after the variable name in the code. When you use a string type variable, you can only assign string values, but they can also be used wherever a string value is accepted. In Kotlin, every variable must have a type, but you generally do not need to specify it explicitly. If you don't specify a type, it is inferred from the value, which means that a variable will take on the same type as the value you assign to it. However, a variable type cannot change, so if a variable contains a string type, you won't be able to assign an int value to it. You should now be familiar with the different types of variables and values and how to use them. Good work. You will probably know that in programming languages, you often must operate on numbers. Let's take the task of building an app to manage a school registration system, for example. It will need the capability to calculate the number of absences, the average grade for each student in each semester, and much more. You can build such code by using Kotlin's ability with numbers. Operations on numbers are also very important for graphics. Let's say you create a game, and your player must see a number of objects. Where will you show these objects? In what size? And what should the number of pixels be? This is where numbers can help you. Over the next few minutes, you will learn how to name and discuss the most basic number types in Kotlin. You will also be able to explain how to create operations between numbers. In Kotlin, there are 4 basic types representing numbers. They are int, double, long, and float. Let's explore these in greater detail. The first type, which you already covered, is called an int. This is an abbreviation of integer, which is a whole number without a decimal part. Did you know that int values can be both positive and negative? To create a negative int value for any variable, you just need to add a minus sign in front of the number. Int values also have a limited size, and their biggest possible value is over 2 billion. That is quite a lot, so you rarely need more than that. But if you do operate using larger numbers, there is a special type called long. Long can accommodate numbers over 9 quintillion. To create a long value, we need to add an L suffix after a number. The L suffix sets the specific type to long for a number. Kotlin will also directly infer long for a number where the value is too big for an int. In this example, the first line of code has a variable named I1, which is a type of int. In the rest of the code, variables I2, I3, and I4 are a type of long. In our second example, the I4 variable is also a type of long, but the number value is written using underscores to separate the major divisions such as hundreds, thousands, millions, and so forth. Numbers that operate with a decimal part are called double. Remember, the type can be inferred by the value supplied. Double comes from the fact that this data type holds a number that is made up of 2 parts, the integer and a decimal. The last value type that represents numbers in Kotlin that contains a decimal part is called a float. You can create this number type by using an F suffix after a number. A float behaves just like double. Now you may wonder what the difference is between these 2 types of numbers. A float has limited precision, which means that it behaves just like a double, but it cannot express too many decimal digits as the precision of this number will be lost. A double has a limited precision as well, but its precision is more accurate. This is because double uses twice as much memory as an int, and that's why its name is double. You should now be familiar with the 4 basic types representing numbers. Did you know that when you use numbers in Kotlin, you can also make basic numeric operations like addition, subtraction, division, or multiplication? So, when you create basic numeric operations, normal math operation precedent is used by Kotlin. This means that, for example, 1 plus 2 times 3 is 7 and not 9. The reason is that you should first multiply before you add numbers. Note that the only exception is if there is a parentheses. If you need to override normal math precedents to create a particular calculation, you need to use parentheses. You should now be able to create operations between numbers. Well done! This is great progress towards your learning goals. At this stage of the course, you've spent some time exploring the value types in programming in Kotlin. You previously learned about text values and other values you can print, such as numbers, a number with a decimal part, or a special value like true or false. However, it's important that you understand the value types for text. Over the next few minutes, you'll learn how to create a car and a string, describe what a Unicode table is, and explain how characters are represented. Recognize that a space or a new line is also a valid character. Explain the string name, and use string templates. So before we start discussing text, let's start with a simpler element that is a single character value. You define a single character value by placing it inside a set of single quotes. This value type is called a char, which is an abbreviation of character. Now that you know what a char is, you may wonder how a computer stores a character like this. Remember that you previously learned about numbers? All characters are represented by numbers. This is because a computer does not see letters but only binary code, which is made up of zeros and ones. A special table was then created that maps each character to a unique number. This table, called Unicode, is essentially universally accepted in programming languages, and in its basic form, it supports 144,697 different characters. Let's explore an example according to the table. The character A is code 65. This means that character A is represented by the number 65. In Kotlin, you can find a character code by using code on a character. Now that you know what Unicode is, can you remember what a sequence of characters is called by programmers? You're right, it's called a string. The word string is so popular in programming that it is treated as a synonym for text. You may even hear programmers talk about passing a string or changing a string. A string can be empty, or it can have one or more characters, including spaces and commas. Strings have some built-in code that will allow you to access some information about them. One of these built-in codes is the keyword length. This built-in code or function can be accessed by using a dot before the word length. This will return the number of letters or the length of that string. You can also add any other value to the end of a string, which means that the value transforms to a string. You will learn more about this later in the course. Another very powerful string feature is called a string template. It allows you to include a variable value in a string. To do this, you use a $sign in the variable name. Let's explore an example. Here, the user is identified by their name and age. This name is stored in the variable called name. If I want to use its value in a string, I use a $sign followed by the variable name. I now do the same with age. As a result, I have a string with the current value of name and age variables. Finally, you can also inject the result of some operation into a string, for example, the addition of two numbers. If you do this, you need to wrap these operations in braces. You're now familiar with using text in Kotlin. Great work! You're making good progress on your journey towards becoming a Kotlin developer. Imagine that you are creating an app where the user has either a free account or a premium one. You would like to set some conditions for the way in which content appears. For example, only showing advertisements on free accounts. In the next couple of minutes, you will learn to do just that by describing how to write if and if-else statements. You will also be able to explain how if-else can be used to conditionally set up a value for a variable. So, to set conditions for the way content appears on your app, you can use the conditional instruction if. You can use the if statement to execute some code, only if the specific conditions are true. Let's examine how this can be written in Kotlin code. I start off with the if keyword, then I add parentheses, and inside these parentheses, I specify a condition. In this case, the condition is that the account type is free. A condition is also a code that returns a Boolean, which means that it's either true or false. Using the same code, I open the curly braces, and here I specify the body, which is the code that should be executed when the condition is met. Here, the code in the body will print the string show ads. Don't forget to close the curly braces. Now let's explore a few examples. In this example, if you use true as a condition, then the body will always execute. Using a condition in this way in a piece of code does not make sense. The same goes for using false as a condition, as the body will not execute. Using a condition in this way means that it will never print, which also does not make sense. Let's return to the app example where the user can choose between a free and premium account. In this case, you want to show advertisements, since the user has a free account. This means the code should print show ads. Let's say that the account type has now changed to paid. When the same condition is checked, it is not satisfied, so the code in the body is ignored and the code prints nothing. You may have noticed that every line in the body of a statement starts with 4 additional spaces. The spaces are known as an indent, and the white space improves code readability. Creating these white spaces is called formatting. This is a very popular practice among developers. It makes code easier to read. For instance, it helps to distinguish between the body of your condition and the rest of the code. You should now be familiar with formatting if statements in Kotlin. Let's unpack another condition called the if-else condition statement. What if you want to do something both when a condition is satisfied and when it is not? For instance, depending on the type of account you want to display, a label saying paid or free. The key point is that you always want to print one or the other. Then, in the else part of the code, you specify what should happen when a condition is not met. So, in this code, if the value of the account type variable is free, the text free account will be printed. Otherwise, the text paid account will be printed. Now you can use if-else to set a variable value. In this example, the code will also assign some value to a variable called text, which is either free account or paid account, depending on the value of account type. What is really great news is that these two assignments can be combined and simplified. You can make if-else decide what value will be assigned if you use it on the right side of a single assignment. That is typically how we use if-else to decide on property value depending on some condition. Whenever the body of the if-else conditional statement has only one expression, you can exclude the braces and only use the content. You should now be able to describe how to write if and if-else statements, as well as explain how to use an if-else to conditionally set a value for a variable. Congratulations on building another important Kotlin skill. You are now familiar with if and if-else statements and how to use an if-else to conditionally set a value for a variable. So far, you also have learned that you can connect multiple if-else conditions into one that executes the body of the first satisfied condition or the body of the last else block, if no condition is satisfied, as I've illustrated in this code example. In Kotlin, there is an alternative to this notation that developers consider easier to read and write. It's called the when statement. In the next couple of minutes, you will learn how to use the when statement as an alternative to the if-else-if statement, and you will also be able to explain how to use when with a value. Let's find out how to use the when statement. Start with the when keyword and then open the curly braces. Inside the braces, write a condition and the body that should be executed. Remember to close each set of curly braces. You can specify what should happen when no condition is true with the else block. In the end, only one body will be executed. It will either be the body of the first satisfied condition or the body of the else block. Let's explore a practical example of how to use the when statement. Here, I am using when to comment on password strength. The first condition it checks for is whether the password is empty. If it is, password cannot be empty will be displayed. If I specify a password that's shorter than 7 characters, then the second condition is accepted, and this password is quite short will be printed. If the password you choose is not empty and longer than 7 characters, then the else branch is chosen and this password is okay is printed. When can also be used as an expression. This means that instead of printing a value, you can just return the value. So this expression will return password cannot be empty for an empty password. It will return this password is quite short if the password is less than 7 characters, and it will return this password is okay if the password meets both conditions. But this value needs to be stored in a variable so it can be printed. I use text to show as the variable. When the body of the branch has only a single value or a single expression that makes a value, you can get rid of these braces. This results in a more concise syntax. Notice that it still prints the password is okay when the password meets the conditions. Password cannot be empty when the password is empty, and this password is quite short when the password is too short. When can also be used in another way. Let's unpack how this works. If you add a parentheses with a value directly after the when keyword, you can specify values to compare your value to. In this code, the value of number is 1, so 1 will be printed. When the value of number is 2, then 2 will be printed. For any other number value, big will be printed. Let's explore another example. This time, I compare string values and answer the question, does the user have access to a document? So, when the user role is admin, they have access to all documents on the system. When the user role is empty, they have no access to any documents on the system. In any other case, check if the user is the owner of the document. You should now be familiar with the when statement. Good work. Loops are one of the basic constructs of any programming language. They allow for the execution of one or more statements until a condition is met. And what is great is that loops can be used multiple times. In this video, you will learn about the idea of loops, but before we get there, let's start with a short summary of how programs are executed line by line and how this flow can be altered with conditions. In general, code is executed line by line. However, if the path of execution steps into an if condition, it checks the predicate, and if it returns true, the control flow continues into the next line. Here, a predicate is a function or an expression that returns a Boolean. This means that this is a piece of code that returns true or false. Let's consider another scenario. If there is an else block, and the predicate returns true, the execution continues into the condition body, but note that it jumps over the else block. Now, if the predicate is false, the condition returns false. It jumps straight to the else block. Remember, when you use conditions, each body can be executed only once, and this may not be sufficient. You may have noticed that all the lines used are executed at most only once per program execution. So, if you want to implement a more complicated program, you need a way to use your code more than once. One of the simplest ways to do this is using loops. Loops are very similar to the if statement, but the main difference is that they can execute their bodies more than once. There are a few types of loops, but in this video, we will discuss the while loop. The while loop statement is written in a similar way to the if statement, but you use the while keyword instead of if. As a result, the condition is checked and accepted. The body is fully executed. The condition is checked again, and if the condition returns true, the body will be executed again and again. This is super, as the body can be executed multiple times, which means it gives you a way to use your code more than once. Now, you may be wondering how loops are used. Let's explore a few examples. A computer game is a great example of how loops work. They typically have some loop that keeps the game running until you have finished playing. Another example is when you have elements in your code and you use a loop to manipulate each of those elements to do something. Let's say you have a list of offers on your website and you want to show each of them to the user. You will use loops to create this effect on your web page. Finally, imagine that you want to develop a code for a drone. This drone code will need some type of loop that reads sensors, alters controls, as well as decides on the engine's power to maintain flight. You should now be more familiar with how useful loops are in Kotlin and how they can be used to execute a segment of code multiple times. You will learn more about loops later on. Great work! On a previous occasion, you learned about the while loop that evokes some code until a condition is satisfied. Let's say you are interested in a more specific behavior to evoke some action for a number of elements that are known in advance. In this video, you will learn more about for loops and how to create for loops with numbers in Kotlin. These can be implemented using a dedicated loop called a for loop. The for loop is a very popular kind of loop. Often, it is used to invoke an action for each element on a list. So, how do you use for loops in Kotlin? In this example, I've used a for loop to iterate over a list. We will discuss lists later in this course. Let's unpack this example from the beginning. The for loop starts with the for keyword, then there is a parentheses, and inside the parentheses, I first define a variable name, letter. I now use the in keyword, and I specify the list to iterate over. By iterate, we mean to repeat an operation for a set amount of times. I then close the parentheses and start braces with the body that should be executed for each item. Let's create something you would do in real-world coding. Here I created a list with 3 elements, A, B, and C. I then used a for loop, and for each iteration I stored the item in the variable name letter, and I call println. As a result, this code will print. The next letter is A, then the next letter is B, and finally, The next letter is C. Now that you are more familiar with for loops, let's take a few moments to explore how for loops can be used to iterate over numbers. For loops can also be used to iterate over numbers. To do that, I specify the number I want to start at, 1, followed by 2 dots, and the number I want the range to end at, which is 5. The last number is included in the range, so all the numbers from 1 to 5 are printed. Such a range is called a closed range, one that includes the last value. But what if I want to have an open range that starts at some number but ends before the last number? For that, I have to use the until keyword so that I have a range from 1 until 5. This means that 5 will not be printed and the range ends at 4. Notice that when you iterate over numbers, you should always start with the smallest value and end with the highest. If you start with the highest value and end with the smallest one, then the range is empty. There's nothing inside because 5 is bigger than 1. Here, the IDE suggests that I should use down to if I want to iterate from 5 down to 1. When I use down to, you'll notice that all the numbers from 5 to 1 are printed. When you iterate over numbers, you can also specify a step. The default step is 1, so the range moves from 1 to 2 to 3, 4, and 5. But you can change the step. For example, you can specify step 2. Now, with every step, it moves by 2, so what's printed is 1, 3, and 5. If you use until and step 2 together, it will only print 1 and 3 because the range doesn't include 5. Step can also be used when you iterate from a bigger number down to a smaller number. For example, when I use step 2 together with down to, the range starts at 5 and moves to 3 and then to 1. This is how you can use for loops to iterate over numbers. Thinking about a code as something that can be invoked multiple times is very important, and it is a big step towards understanding programming. You have now learned more about for loops and creating for loops with numbers. Great work! You've reached the end of this module on Introduction to Programming in Kotlin. Great work! During this module, you'll learn that Kotlin is a powerful language that allows you to code more efficiently, thus boosting your development productivity using Kotlin variables, conditions, and loops. You may remember that we started with various variables, values, and types. You learned that they help you to group and store items and also helped you to avoid repetition, so you don't need to continually redo everything. Next, you explored the different types of conditions and how they are used in Kotlin. And lastly, you discovered that loops allow for execution of one or more statements until a condition is met. It's now time to recap the key lessons you learned and the skills you gained. With that in mind, let's summarize the key points you learned in this module. During this lesson on Introduction to Programming in Kotlin, you learned how to explain the concept of variables, values and their different types such as strings, Boolean, doubles, and integers, identify the most basic number types in Kotlin, for example, integers, double, long, and float, and explain how to create operations between numbers. And you can also explain how to use text in Kotlin by, for example, using a char or a string. You are also able to recognize that a space or a new line is a valid character. The next lesson that you encountered was an introduction to if and if-else conditional statements, as well as when conditional statements, which helped you set conditions for the way content appeared. You have learned how to write if and if-else statements, and you can explain how to use if-else to conditionally set a value for a variable. Following your completion of the conditions lesson, you moved on to a lesson on loops. You discovered that loops allow for the execution of one or more statements until a condition is met. During this lesson on loops, you learned how to explain what loops are and how to use loops when coding in Kotlin. You also learned about for loops and how to use for loops with numbers. You're now familiar with the basics of programming in Kotlin, along with concepts like variables, conditions, and loops. Excellent! You've made great progress in your Kotlin programming journey. In programming, you'll often need to execute the same operation multiple times. What will be great is if you can write the code once and reuse it in other parts of your code. This is exactly what functions in Kotlin can do for you. In the next few minutes, you will learn what a function is and how you construct programs in Kotlin from functions. You will also learn how to use functions so that they can represent different levels of abstraction. In computer programming, a function is a set of instructions that you execute to accomplish a specific task. Functions usually take in some data, process it, and return a result. You execute a function by invoking or calling it. Now that you know what a function is, let's build a custom function that uses print to describe the daily routine of Jack, who absolutely loves fruit. He eats fruit for breakfast, lunch, and dinner. So what would Jack's day look like if you represented it in code? First, he wakes up, then gets dressed, prepares his fruit, and eats it. After this, he does his work, prepares another fruit, eats it, then plays games, prepares another fruit, eats it, and finally goes to sleep. You may have noticed that the repetitive tasks are preparing and eating the fruit. Writing these tasks over and over takes time and also makes reading the code quite difficult. So, how can you improve your code? You can extract those repeated lines from your code by building a function called prepare and eat fruit. Now you don't have to repeat the code, and you guessed it, your solution is easier to read. Functions are a daily part of writing code, and this is also true for programming in Kotlin. You may already be used to calling and defining functions without even noticing it. For example, you've already been using println, which is actually a function call. You may also remember using the main function previously. Main is another example of a function. The main function has a special meaning when you use it in Kotlin. Your program looks for this function as the starting point for the path of execution. In other words, the starting point for your program. Not only can you use functions to reuse repeated code, but you can also use functions to organize your code in a way that is readable and easy to understand. When using functions, there are various rules to adhere to, but for the purposes of this video, you will only focus on one of these rules. The rule states that each function should use operations in a slightly lower level of abstraction, which means a higher level of detail. Let's explore an example of this rule of abstraction in greater detail. If you were to describe a person driving to a store, using a very low-level implementation could be grab the car keys, get in the car, start the car, and drive to the store. The idea here is to break the actions down into their component parts. A code representation of these tiny steps is that you first grab the keys, then get in the car, after this, start the car, and finally, you drive to the store. More tiny steps going to a lower level of abstraction inside each of your functions, where you can state in greater detail that you open the door, get in the car, put the keys in the ignition, and start the engine. This is how you can use functions to optimize and organize your code. The names you use for your functions will also help other programmers read the code to understand the meaning of each function and navigate through the code. When your code is well organized, anyone can easily find what they're looking for. It's just like scrolling through the table of contents in a book. Good work! You're making great progress in advancing in your career as a Kotlin developer. As you may know by now, functions play an important role in programming languages. Up to now, you have learned that you use a function to break the code into smaller, more understandable and reusable parts, which makes the program more manageable and easier to understand when you code. In this video, you will explain what happens when a function is called, name the function's conventions, and define the main function. In Kotlin, you can define functions starting with the fun keyword. Then you specify a name, use parentheses, specify parameters inside the parentheses, and finally open a curly brace for the function body. Don't forget to close your curly braces. To call a function, you use its name and a parentheses. So you might be wondering what happens when you call a function. Well, what happens is that you begin executing the code in the body of the function. Let's say you define a function called cheer that prints hello. It means that every time you call the function cheer, it prints hello. In Kotlin, functions are declared with the fun keyword. This means that you can assign functions to variables, pass it an argument, or return it from another function. Now that you know what the fun function is, you are maybe wondering what the purpose of the body is. The body is the place where you can call other functions, use conditions and loops, and much more. This now leaves us with the question of how do you name a function? Let's explore some guidelines for naming a function. You can name a function the same way you name a variable, and this means you use camel case. You use camel case as this is a standard practice of writing naming conventions, formed with multiple words and joined together as a single word by removing the spaces. The first word always starts with a lowercase letter, the second word and every word after that gets capital letters. The big single word forms the name of a function. It also must be unique, and you should try to use a name that describes what the function does. Let's explore a few examples of good function names in camel case. So, now that you know what functions are and how to name them, let's discover how functions work. To build a better understanding of functions, let's analyze what happens when you call a specific function. In all coding programs, the code gets executed line by line from top to bottom. Now let's say that the function print_cd contains two print statements, one for C and another one for D. So when you call this function, each print statement is executed in order. Next, you implement the main function. Remember, this is always the start point for your program. The first line to execute calls the println function and displays A. The next line also calls the println function, but it has a different parameter, so displays B. The next line calls your printcd function, which has its own call to the println function. So it displays the C and then the D. The next line also calls the println function, and this time displays E. And lastly, your printcd function is called again, which outputs the C and the D. You now know how functions work when programming in Kotlin. You should be able to explain what a function is and describe what happens when a function is called. You should also be able to name the function's conventions like the fun keyword, and you also learned how to define the main function. Good job! Imagine implementing the code for a robot that can shop on your behalf. You decide that one of its tasks will be going to a store. This action can be defined by a function, but not a regular one, as there are many stores that your robot can go to. So it needs to be a function with a parameter. In the next couple of minutes, you will learn what the role of a parameter is, how to differentiate between a parameter and an argument, and that a function can return a value. Now let's go back to our robot example. There are multiple stores that your robot can go to, so when you call this function, you should specify which store to shop in. These types of actions can be executed using functions, because each function can specify the values it expects you to pass when you call them. To do this, you need to specify parameters. A parameter is a name variable that is defined as part of a function. So in our robot example, we can pass the name of any store to the Go Shopping function. Then, each time we activate our shopping robot, we can send it to a different store. So, how do you use parameters in coding? You specify parameters in the parentheses after the function name. They look like regular variables, but without the val or var keyword. As an example of a function, you might define the store name parameter of type string in a function named goToStore. This variable can be used in the function body. So, when you declare or write a function and you use a parameter, when you want to call this function, you must supply the parameter. The value supplied for this parameter is called an argument. In this example, the values Little Lemon and Lucky Shrub are arguments. So what is the difference between a parameter and an argument? When you write or declare a function and you specify the parameters that you want your function to use, you must supply those parameters when you call the function. Supplying the parameter is known as passing an argument. Now let's explore the println function. Println has a parameter for the value to print, and this is, therefore, the argument to be supplied. You will encounter more examples of functions with parameters later in this course. Functions can also be used to produce a result value. Let's consider mathematical functions like double, sine, or absolute. These functions produce a result based on some argument values. To return a value from a function, you use the return keyword. Let's start with a function that doubles the argument value. First, define a function called doubleIt with a parameter value. There are two things you need to do to make it a return value. First, you define the type of the value you want to return. In this case, it is int. Here you need to specify it as part of the function definition in the parentheses. It is important to note that you specify a type using a colon followed by the type name. Now, inside the function, you need to return the value using the return keyword. This keyword immediately ends the function body, so code placed after it is unreachable. When you call this function, it will produce the result, which is double the argument value. Let's explore one more example of a function with results. The absolute function is a function that returns an integer value without a sign. So this does not change positive values, but it turns all negative values into positives. You can implement the absolute function by using an if condition. If a value is positive, it will return unchanged. If a value is negative, it will return this value with a changed sign. Both parameters and result values are helpful in programming and are widely used in all kinds of projects. You should now be familiar with the function of parameters and how to differentiate between a parameter and an argument. You also now know that a function can return a value. Good work. Let's imagine a room, and in this room there are objects, like a bed, a table, and a lamp that you can use. Programming also has objects, which you can define and operate on. To create objects in programming, you use classes, but it is also natural to group objects into types. In the next few minutes, you will learn about the differences between a class, an object, and a type, and how they work. You will also be able to define an empty class and create an object with it. In Kotlin, every value is an object. This means that strings and integers, which you learned about previously, are also objects. However, you can define other kinds of objects as well. To define custom objects, you use classes. A class is like a template that defines what an object looks like and how it can be used. And in Kotlin, we use it to create objects. Now let's explore the relationship between classes, objects, and types. A class, as mentioned before, is a template that you use to create objects. It specifies how the object should be created and which methods and properties it consists of. It also defines what the object's relationship is to other classes. An object, on the other hand, is a specific instance that you create using a class. Now let's investigate what a type is in relation to objects. You may remember that you learned about types previously in this course and that a type defines which object the variable can accept. A type represents a category of objects. An example of a type is an int. Int is a type that represents all integer numbers. Number is a type that represents all kinds of numbers, so both integers and real numbers are a type number. Let's explore this relationship between classes, objects, and types in greater detail by using examples. There is a class called int that is a template for integer numbers. An integer, like 42, is an object, so it is an instance of the class int. Let's now examine how the same information applies to a custom object. You can use the custom class called employee to create an object. It also makes a type called employee that can be used to specify that a variable holds only objects made using the class employee. Now that you understand the relationship between a class, an object, and the significance of types, let's go over how you can create custom classes and objects in Kotlin. To define a class, you will use the class keyword and then specify a name. You don't need anything more for an empty class. The name you specify should start with a capital letter, and you should only use letters to name classes. If you want to specify a name from multiple words, start each new word with a capital letter. Let's return to the class example. You have now defined a class called employee. That represents the employees in your company. To create an object using this class, you need to call a constructor, which is the name of the class and in parentheses. You may note that this is the same as calling a function, but here an object is returned. You can specify the type of variable mark as employee, and this makes it explicit so that this variable holds an instance made from class employee. You should now have some understanding of what a class, an object, and a type is, and what the differences are between them. You should also be able to define an empty class and explain how to create an object using it. Great work! Previously, you learned how to define an empty class using the class keyword and a class name. In such a class, you can create objects using the class name and a pair of empty parentheses. Here, I've created two separate objects, employee 1 and 2, but an empty class by itself isn't useful. Rather, you use classes to model the world. Typically, you use classes to store information about particular objects. Here I have created two employees and I can store information about them like their names and positions. To do that, I need a set of parentheses, which is the constructor definition. Then I need to specify properties. For example, I add both name and position as string types. Specifying properties is a lot like specifying variables. I start with val because I want to make the name property read-only, and I use var to make the position property read-write. The line of code thus reads keyword, name of the property, colon, and the type, which in this case is string. Each employee now has name and position properties. Kotlin expects me to specify some values for the name and position. So I make employee 1 Alex, and their position is manager, and employee 2 is a waiter named Bob. Once you have defined the properties, you can read them. To do this, use the reference to the object, employee 1 in this case, then dot and the property name, which can be either name or position. I'm reading the first employee's properties, so the name is Alex and the position is manager. To read the second employee's properties, I use the reference to the object, employee 2, and I specify that it's Bob, who is a waiter. Not only can you read a property value, you can also modify it. To change Bob's position from waiter to manager, I use the position property on an object that represents the employee, in this case employee 2, followed by the equality sign and the new value, which is manager. Note that this can only be done for the var properties because val properties can't be changed. And now when I ask for the property on this object by running the code, the new value manager is displayed instead of waiter. There's another way to specify properties. What I did was to specify them as part of a constructor definition. In other words, a function that is used to create an object. That's why the value of those properties had to be specified during object creation. The second way to specify properties is to do it inside a class body. First, I specify a body with the curly brackets. This is a body definition, and inside of it I can specify the property. But such a property needs to have a value specified. So, if I specify a property named label, I have to immediately specify the value of that property. I can't have a property without a value. Leaving the property without a value is not valid because I'm not using a constructor definition. Properties can all be accessed the same way, so I can ask for the employee label. I use var, so label can be changed to, for example, new label. One very important thing is that I can use the primary constructor property when specifying a value for a regular property. So I can use name and position here, which means that asking for label will give me both the employee's name and their position. The label of employee 1 is their name, Alex, and their position, manager, in brackets after their name. Now you know how to use classes to store information about objects. Well done. Most objects have actions associated with them. For example, a coffee machine is used to make coffee. A car can be used to drive you to another place, and a barista can make you a coffee. In programming, you model such actions using methods. Methods are functions that are specific to a certain class. They are defined inside the class body, in other words, inside the curly braces, and they look just like regular functions. So first the fun keyword, then the method name, like make coffee, then the curly braces for the body where I print making coffee. To call methods, I need to have an object of this class. Here I have a barista, and on this object I can call make coffee. When I run this, it prints making coffee. A special thing about methods is that they have direct access to all the properties of a class, which in this case includes the name property of the barista. So in this case, when you run the code, it prints Jake makes coffee. Methods are functions, and just like regular functions, they can have specific parameters and result values. I'm going to specify a coffee type and size, and the result will be a coffee. Now I need to create a class to represent that coffee. Inside the method, I return the created coffee with the type and size. Here I also specify that the barista will make a coffee of a certain type and size. The result of such a method call is, of course, a coffee. And by specifying the type as latte and the size as 1, prints out Jake makes coffee of type latte size 1. Another special attribute of method is that they can implicitly call other methods from the same class. To call make coffee outside of the class, I need to provide an object, the barista in this case. And if I specify another function, cheer and make coffee, in the same class, passed with the same values, I can call it directly. So I call make coffee by specifying the type and size of the coffee, and now I can directly call barista.cheer and make coffee. As a result, the code first prints hello, and then Jake makes coffee of type latte size 1. In this way, methods can directly call methods from the same class. Methods are important in programming, and two of the most important types, string and int, have many methods. Let me demonstrate a couple of basic methods from the string class. A string object can't change, so its methods are used to produce a new string that's a modified version of the previous one. For example, when you use the uppercase method, the result is a new string that's an uppercase version of the original one. You can also do this with lowercase method, and all the characters will be lowercase in the new string. Another popular string function is replace, which will also return a new string. The modification is that all the substrings will be replaced with different ones. For example, I can replace the word some with the word a. So, as a result, this is a text is printed instead of this is some text. This video has demonstrated how useful methods can be. They help encapsulate behavior that is typical to an object. You will be using methods in this course, and you will encounter many more examples in other videos and readings. Programming languages are built upon certain models to ensure that code behaves predictably. You are already aware that Kotlin treats everything as an object, which is why Kotlin lends itself so well to the object-oriented programming paradigm. Kotlin primarily follows what is known as the object-oriented paradigm or model. As you'll soon discover, object-oriented programming, or OOP, relies heavily on simplicity and reusability to improve workflow. By the end of this video, you'll be familiar with the object-oriented programming paradigm. This knowledge will reinforce the knowledge you have already gained about Kotlin. You'll also be able to identify the four main concepts that define object-oriented programming. Programming paradigms are a strategy for reducing code complexity and determining the flow of execution. There are several different paradigms such as declarative, procedural, object-oriented, function, logic, event-driven, flow-driven, and more. These paradigms are not mutually exclusive, so programs and programming languages can opt for multiple paradigms. For example, Kotlin is primarily object-oriented, but it is also procedural and functional. In simple terms, a paradigm can be defined as a style of writing a program. OOP is one of the most widely used paradigms today due to the growing popularity of languages that use it, such as Java, Kotlin, C++, and more. But the OOP's ability to translate real-world problems into code is arguably the biggest factor in its success. OOP has high modularity, which makes code easier to understand, makes it reusable, adds layers of abstraction, and allows for code blocks to be moved between projects. To help you better understand OOP, I'll first clarify some of its key components, which are classes, objects, and methods. You are already familiar with these concepts and have had some practical experience of using them. A class is a logical code block that contains attributes and behavior. In Kotlin, a class is defined with the class keyword. The attributes can be variables, and the behavior can be functions inside of it. You can create instances from these classes, which are called objects. In other words, a class provides a blueprint for creating an object. In more practical terms, let's say you want to record the attributes of employees at the Little Lemon restaurant, such as their position and employment status. You could create a class called employee and conveniently bundle those attributes in one place. Next, let's discuss objects. As mentioned, an object is an instance of a class, and you can create any number of them. The state of an object is comprised of its attributes and behavior, and each one has a unique identifier to distinguish it from other instances. The attributes and behavior of the class are what define the state of the object. For example, you can create the object emp1 by calling the employee class. Once called, you can define the position and employment status attributes as shift lead and full-time, respectively. In code, this would be written as emp1 equals employee followed by shift lead and ft in parentheses. This is a case of instantiation or creating an instance of a class. Finally, there are methods, which are functions defined inside a class that determine the behavior of an object instance. Now that you have refreshed your memory on the building blocks of objects, let's dig into some of the main concepts of OOP. The first one is inheritance, which is the creation of a new class by deriving from an existing one. The original is called the parent or superclass, while any derivatives are referred to as the subclass or child class. The next concept is called polymorphism. It's a word that means having many forms. In the context of Kotlin, polymorphism means that a single function or object can act differently depending on the object or function that uses it. For example, the built-in plus operator works differently for different data types. In the case of integer data types, the built-in plus operator performs additional operations such as 3 plus 5 equals 8. On the other hand, in the case of string data types, the built-in plus operator performs a concatenation or combining two strings together. This ability of modifying functionality is called polymorphism. The third concept is encapsulation. Broadly, this means that Kotlin can bind methods and variables from direct access by wrapping them within a single unit of scope, such as a class. Encapsulation helps prevent unwanted modifications, in effect reducing the occurrence of errors in output. And finally, there is the concept of abstraction. This refers to the ability to hide implementation details to make data safer and more secure. There are other important concepts in OOP, such as method overloading, method overriding, constructors, and more, which you'll learn about in more detail later. In this video, you became familiar with OOP paradigm and the four concepts that support it: inheritance, polymorphism, encapsulation, and abstraction. The following lessons will concentrate on the practical implementation of these concepts. See you next time! Polymorphism is one of the most important programming concepts when it comes to objects. Polymorphism is a possibility to specify a type that accepts objects produced using different classes. Let's say that we need a function to do something with an animal, no matter what kind of animal it is. The type of animal should, for example, accept both a dog and a cat. In this case, an animal can be both a dog and a cat, so it can take many forms. That's why it's called polymorphism, which means many forms. To have an object that can take many forms, I would need to specify what I can do with the object, and for that I can use interfaces. First, I define an interface using the interface keyword, and then I must specify the interface name. In this case, it's animal. Then I specify the functions and properties of the interface inside the class body by using the curly braces. For example, I specify breed as a property and the action of petting as the method. Notice that the property shouldn't have a value. That's because it's only a definition of what I expect the objects, the animals, to have. For example, all animals have a breed, but I'm not specifying what it should be. It is the classes that are responsible for specifying this property value. When I specify the function, I don't specify the bodies either, for the same reason. It is the classes that should specify what happens when you pet an animal. The animal interface only specifies that if a class is an animal, then you can either ask for its breed or you can pet it. With such an interface, I can define classes that will be implementing this interface. For example, I can define a cat class that will be implementing the animal interface. To implement the interface, you have to use a colon and the interface name. Now, because the animal interface specifies breed and the action of petting, I need to provide that information. But how do I define it? Cats can have multiple breeds and they can also have names. So I specify two properties, one for name and one for breed, and both are string type. I specify the breed property that I expect the animal to have, but defining it isn't enough. I also need to use the override keyword. The override keyword informs the reader of the function that this property is also specified by an interface, and therefore it can't just be changed because it might result in the animal interface not being fulfilled anymore, because it requires breed as a property. I also need to specify the petting function and again use the override modifier for the same reason. Right now, the class cat is correct, but I need to add what happens when someone pets it. When you pet a cat, it might make the noise meow. I can have a similar class for a dog, and a dog will go woof when someone pets it. When you define a function, you can specify that you expect an animal as an argument. You don't know if the animal is a cat, dog, or another class of animal, but no matter what it is, you know it will be an animal. When I call this function, I specify that it's a cat named Jack and its breed is Munchkin. When I call the function again, I specify that it's a border collie named Cookie. Both dog and cat are accepted as classes because they implement the animal interface. However, this function won't accept anything that's not an animal. For example, it won't accept a string or an integer. It will only accept classes that are implementing the animal interface. Now, inside this function, I know that I have an animal, but what can I do with that animal? I can do what I defined in the animal interface. I can pet the animal, or I can ask for its breed. I can't ask for the name because it doesn't necessarily need to have a name. But it does need to have a breed property and a pet function because that's what's specified by the interface. So when I run the pet function, the two different results of those calls display that the cat made a meow sound and the dog made a woof sound in response to being petted. Properties can be overwritten by constructor properties, but also by regular properties defined in the body. Let's specify another animal called emu with no name and with the general breed of emu. And I leave pet as an empty function because it doesn't make a sound when petted. This is a correct class just like the dog and cat. It has the breed defined and it has an empty pet function. Now I add a print call in the pet animal function that says what animal we are petting. When I run my code now, I should first see patting Munchkin and then patting Border Collie and then patting Emu. In conclusion, polymorphism is a powerful concept because it allows you to specify a set of expectations on objects, and different objects can fulfill those expectations. This makes your code more adaptable. You will learn about more examples of polymorphism throughout the course. Let's say you're a drone manufacturer and you have a line of drones that you control using the following drone class. Then a superhero trend takes off and your marketing department asks you to produce a new variation of your drone with a new look. How can you do that? A suboptimal solution would be to copy and paste the drone to make a superhero one with a different look. But that's not a good solution because it only works in the short term. Your superhero drone has to have the same methods of the original drone, so whenever you need to make a change, you need to apply it in two different places, both on the drone class and the superhero drone class. Another problem is that the superhero drone is not actually a drone, so you cannot use superhero drone when drone is expected. That's no good. It needs to be a drone with the same methods but with slight modifications. How can I make it so? I can use a special feature called class inheritance. I must define a class that extends from another class and introduces some modifications to the behavior. This is what class inheritance looks like. To allow class inheritance, the class that I want to inherit from needs to allow it, so it must be open. In other words, there must be an open modifier. Now I can inherit from the drone class. As a result, the drone is the parent of the superhero drone, so all the drone behavior also applies to the superhero drone, which in turn can also be used as a drone. Notice that inheriting from a class looks just like implementing an interface. So, I use a colon after a constructor and then the class name. And this is a class constructor call. To modify something in a subclass, the property or function needs to be open. If I want to modify the look property, I need to make it open. I also need to use the override modifier to explicitly say that I can change the look of this class. This is a valid child of a drone. It is a class that behaves just like a drone, but it has a different look. And if I change the implementation of the parent class, then the implementation of its children will change as well. So now let's play with that. Let's say I want to modify some methods as well. For example, the superhero drone should set off in flight a bit higher than the regular one. For that, the setoff function needs to be open to allow overriding. And now I can override the setoff function and move the superhero drone's flight a bit higher. When you override this function in the child, it changes how this function will behave in that particular child. So if I have a regular drone, its behavior is still the behavior of the original drone, but the superhero drone has a slightly different setoff function. Note that the superhero drone sets off by moving 15 centimeters up in the air and then 10 centimeters forward. The regular drone only moves 10 centimeters up in the air and then 10 centimeters forward. Now let's make one more modification. Let's say the superhero drone must announce that it's moving whenever it moves. To do that, I need to make the move function open, and I need to override it for the superhero drone. And I print superhero is moving. I have overridden the original body of the move function, which means that when you call move on the superhero drone, this is all that's going to happen because the new body overrides the previous body of the move function. So right now, the superhero drone will only announce that it's moving without really moving. Notice also that the setoff function that's supposed to move up is only announcing that the superhero drone is moving and not actually moving up. This is a function defined in the parent, but it calls the move function that is overridden in the children. So if you override a function in the children, you can change the behavior of functions coming from the parent that might be using the functions you've overridden. What I want to achieve is to first announce that the superhero drone is moving and then call the original move function. To do that, I need to call the original function defined in the parent by using super.move. The super keyword indicates that I'm referencing the function from the parent. So when I override a function, I call the original function inside of it. Doing this results in the superhero drone not only announcing that it's moving, but actually moving too. And that's just a few ways in which you can use class inheritance. You've reached the end of this module on Introduction to Programming in Kotlin. Great work! During this module, you learn that Kotlin is a powerful language that allows you to code more efficiently, thus boosting your development productivity using Kotlin variables, conditions, and loops. You may remember that you started with what functions in Kotlin are. You learned that functions usually take in some data, process it, and return a result. You also learned that you execute a function by invoking or calling it. You now know that you can use functions to reuse repeating code, and you also learn that you can use functions to organize your code in a way that is readable and easy to understand. Next, you explored classes and objects, and you learned that in Kotlin, every value is an object. You also discovered that you can use classes to define custom objects. And lastly, you discovered more about interfaces and inheritance in Kotlin. It's now time to recap the key lessons you learned and the skills that you gained. With this in mind, let's summarize the key points you learned in this module. During this lesson on functions, classes, and objects in Kotlin, you learned how to explain what a function is, how to use functions to construct programs, and how functions represent different levels of abstraction. Explain what happens when a function is called, name the function's conventions, and define the main function. You also learned what function parameters are, the difference between a parameter and an argument is, and that a function can return a value. The next lesson that you encountered was all about classes, objects, and types. You also learned more about properties, the primary constructor and method when programming in Kotlin. Now that you've completed functions, classes, and objects in Kotlin, you have learned about the difference between a class, an object, and a type, and how they work. And you can now define an empty class and create an object with it. Following your completion of the classes and objects lesson, you then moved on to receive a lesson on interfaces and inheritance. You discovered programming concepts like interfaces, polymorphism, class inheritance, and visibility modifiers, and how to use them. During this lesson on interfaces and inheritance, you learned what interfaces, polymorphism, class inheritance, and visibility modifiers are and how to use them. You're now familiar with functions, classes, and objects in Kotlin, along with concepts like interfaces, polymorphism, class inheritance, and visibility modifiers. Excellent! You've made great progress in your Kotlin programming journey. You already know how to make regular classes, but this is not the end. There are also special kinds of classes, each with a dedicated purpose. In this lesson, you will explore these special classes. There are a number of special classes you can use to obtain a specific type of functionality, such as data classes, enum classes, exception classes, sealed classes, and annotation classes. One particular type of class is a data class. Data classes are a special kind of class dedicated to serve as a holder of data. They help to compare, display, read, and modify this data more easily. Sometimes you may want something to have a very definite answer to a question. For example, if you were programming a coffee machine, there would only be a set number of choices available. With an enum, you can specify attributes to each choice to ensure that the type of coffee selected is always responded to in the same way. So, an enum represents a set of possible options. With programming, sometimes things don't go as expected and your code will break. Then you have to try and figure out what went wrong and where did it go wrong. Kotlin uses a special kind of class called exceptions to deal with the most common things that can go wrong. Things like a missing resource, a file that you wanted to read into your program, or an image that you need to place on the screen. If one of these things is not where you told your program to look for it, then Kotlin and many other languages will not crash, but will use an exception to identify the problem and gather information about it. When you write a program, you want the program to behave in a particular way, with no surprises. But you may not be the only one working on the application being developed, and other developers are going to interact with your code. If you have a special class you have written and you are deriving or inheriting from that class, you may want to control that aspect of the program. Sealed classes allow you to do that. A sealed class represents a closed hierarchy of possible subclasses. As your programs become more involved and complex, you may want to supply developers working on the same project with some additional or supplemental information. You do not, however, want this information to be separate from your program, but included within it. You also would not want this to interfere with or change the behavior of the program. Annotations in Kotlin is a special type of class that allows you to add additional information about elements of our code. Include parameters and attributes that will not affect the running of your program. In short, annotation classes are used to add additional information about your code. They are also used by libraries that analyze your code. This was a brief overview of the types of classes you are now going to learn about throughout the following lessons. You will use practical examples to illustrate the usefulness of these built-in special features of the Kotlin language. Basic values, like strings, can be compared using the double equality sign. The result is true if these are the same values, or false if there is a difference between them. But what happens if I compare two instances of a custom class? So, here I have a regular class called dog and a few instances. Here I have dog1 named Cookie, who is 1, and I also have dog3, also called Cookie, and is also age 1. These are identical and have the same name and age, but if you compare these two objects, they will not be considered the same. These are two separate objects, and all objects are, by default, unique, which means that every instance of a regular class is considered as unique. You will only have true from two objects comparison if you have two references to the same object like in here. In both sides, you can see dog1, so every object by default is unique. You can also print values. So if you print string A displays. If you print number 42, 42 displays. But what happens if you print an instance of a class, or if you transform an instance of a class into a string? The answer is that, by default, a class generates a string that is its name. Then there is @ and some numbers and characters that identify this object. The purpose of those letters and characters is to help you recognize if two values are identical or not. Here I print dog1 twice, so I have dog with the same number, and here I print other dogs. As a result, I have dogs with different numbers. So the equality and transformation to a string gives little information and ignores all the properties. It is fine for objects that should be considered unique, but there are also other cases. These are the cases where I want a class to represent the data it holds. If I think of this dog class as a holder of data, a holder of name and age, then the two dogs should be considered equal if they have the same name and age. These objects should display information about its properties if I ask to transfer the dog into a string. For these situations, there is a dedicated modifier called data modifier. If I add this modifier before a class, then the behavior of the equality operator and transformation of the string changes significantly. Here, two identical objects were considered equal, and they are still equal. Over here, two different objects that were considered not equal are still not equal. Dog1 and Dog3, who are both called Cookie and have the same age, were not considered equal, but they are equal now. This means that the behavior of equality has changed. So when I use the data modifier, the two objects are now the same if they are the same class and have the same data. Because I have dogs with the same names and age, they're considered the same when I use the data modifier. The transformation to the string has also changed. At first, it was just the dog and some number and characters. But now the dog properties together with their values display. It starts with the dog class name, bracket, and with each primary constructor property, there is the name of the property, equality sign, and its current value. This is extremely useful as I can see what is in the classes. This is not all that changes when I introduce the data modifier. The other feature that it introduced is called destructuring. When you have a dog, but you are interested in reading its name and age, the classic way to get them is by separating using the name and age properties. Thanks to the data modifier, I can now just state that I am interested in reading the name and age of the dog. The first variable is name, and the second variable states the age. Destructuring is based on the position of elements, and it doesn't matter how those variables are named. The first variable is associated with the first property from the primary constructor, and the second variable is associated with the second property. It does not matter what name I give it. It can be called first name, and it still works. It is useful, as I can give different names to variables, but you also need to be careful. If you by accident give incorrect positions to your variable names, Kotlin gives a warning, but it still compiles. Under the variable name, the age of the dog displays, and under the variable age, the name of the dog displays. This is incorrect. The position of the variable is important and not its name. Another feature that the data modifier introduced is called a copy function. It is useful for classes like this one that have only val properties, and I want to produce a slightly modified variant of the objects. Let's say, for example, that your dog got older and you want to create a new instance of the dog class using the same data, but just changing the age of the dog. You will not be able to modify the object inside because all of its properties are val. However, you can make a new dog object that is a slightly modified version of the current one. To create a modified version of a data object, I use the copy method that is generated by the data modifier. When I use the copy method, I can specify what I want to change, and I can, for instance, specify that I want the dog's age to be changed to 2 or changed to the previous age to the current age plus 1. I will now have a dog with a new age, which is 2. The copy method creates a new object and does not modify the current one. So if this were dog2, the previous dog would still have the same age. This is a particularly useful function, especially if you are using large systems where they prefer using val instead of var properties. You should now be familiar with data classes in Kotlin and how they work. The Little Lemon cafeteria accepts 3 forms of payment: cash, card, and check. For each transaction, you have to specify the payment method. But how can you represent it in code? A straightforward way is to use a string. Here I use a string, and here I can compare different possible string values. But when using this technique, there's no guarantee that the string is correct, so the method is prone to mistakes. This transaction is for a cash payment. If I have a typo, my code will still compile, but the result will be incorrect. How can I improve on that? A better way to represent possible values in Kotlin is using enum classes. Enum is a special kind of class that represents a set of possible values. It's defined first by the enum modifier, followed by the class keyword, and then the class name. In this case, it can be payment method. And in the body of this class, I specify the possible values, which are cash, card, and check. So instead of using a string, I'm using an enum class named payment method. You also need to use the new class name to specify a payment method value. Notice that I start typing payment method and it auto-completes the value options cash, card, and check, so I just need to select one. Those are all the possible values that can be passed to this function as a payment method argument. It can only be cash, card, or check. Nothing else will be accepted, so I choose check. Here, depending on the chosen payment method, I call a different function. But when a string is used, I also need to account for a situation where an unknown payment method is provided. This is because a string can't guarantee that the passed value is cash, card, or check. On the other hand, enum class does give such a guarantee. In a when expression, it's enough to use all three possible values and handle them in their own ways. An extra else branch isn't needed because Kotlin knows that all the possible payment methods are covered, and that there's nothing else that can be passed. Of course, if a new payment method is added, like PayPal, the when expression needs to be extended to cover another payment method. But even without it, I know that at least 3 other methods are covered. Let me share some other advantages of enum classes. First, enum classes can be easily transformed into a string. If I print paymentMethod.cache as a string, it will display the cache value, which is a nice support when I do programming and I learn about how the program works based on these prints. Also, each payment method has an ordinal that tells you what its position is in the enum declaration. An ordinal is like a position and the count starts at 0, which is typical for programming. The ordinal of cache is 0 because it's the first position. The ordinal of card is 1, and the ordinal of check is 2. Another useful feature of enum classes is that you can easily iterate over payment methods. So I can use a for loop to iterate over payment method.values. This is a function that returns an array of payment methods. You'll learn more about such collections later. For now, all you need to know is that you can use it to iterate over all payment methods. And you can use it to, for instance, print the method name. If you have a string with a payment method, for example, string1 is cash, then you can transform it into a payment method using payment method.valueof and string1. This function gives you the cash payment method. You can print it and it'll print cash. You can also transform it back into a string using payment method.name. Note that this is a string and this is a payment method. You can easily switch between enum class value and string using the value of and name functions. As demonstrated in this video, enum classes offer a lot of positives, and it is good to use them to represent a set of possible values. You should now be familiar with what enum classes are, their benefits, and how they are used in Kotlin. An exception is an unwanted event that breaks the standard flow of your program. Exceptions happen when you try to make an illegal operation. Let's explore a few examples. It is not possible to divide a number by 0. If you do this, your program will be stopped with an arithmetic exception. In the report from this exception, the name of this exception displays, which is arithmetic exception, and also a message that informs you what went wrong. It also states that you tried to divide a number by 0. Another line displays where the exception was thrown, so that you can see that this exception happened in this function and line. Let's explore another example. When you try to read an integer from a string, you can use a method called toInt from the string class. This method should transform this string 1, 2, 3 into an integer 123. However, if you try to transform a text that is not an integer into an integer, it throws number format exception that contains information about what string you used. In all these cases, your program will not be able to continue when an exception occurs. So does this mean that any incorrectness in my code breaks the program? Definitely not. I can identify an exception and I can then stop it. To catch an exception, I use something called the try-catch block. I type the try keyword, followed by braces, and inside those braces, I include the code where I expect an exception to occur. I then include catch block. In this way, I will catch any throwable. It's called throwable Since an exception is sometimes referred to as a throw statement, I then print caught. On the next line, an exception should happen. I catch it using the catch block, and then I print caught. The program continues and done is printed. Note that when an exception occurs, done was not printed because the exception broke the program. If the code is correct and does not throw an exception, catch is not executed. So I just execute this code. I print 1, 2, 3, and then I print done. So this code is only executed when I catch an exception of a certain type. Inside catch, I can specify what kind of exception I would like to catch. The exception here is supposed to be number format exception. I can specify that we concretely expect such an exception by specifying a type in catch block. However, if you specify that you expect a different kind of exception than what you actually throw, it will not be caught. So if you expect the arithmetic exception and the exception thrown is number format exception, that is not an arithmetic exception and you will not catch it. This means that the program is broken again. So here an exception occurs and it is not caught by try catch because its catch does not catch the exception that occurred. So the exception passes through and breaks our program. We can also have multiple catch blocks to cover multiple exception cases. So in the case of arithmetic exception, I will print caught arithmetic exception, and in the case of number format exception, I will print caught number format exception. There is a hierarchy of exceptions, and at the top of this hierarchy, there is throwable, which is a super type of all the exceptions. So if I catch throwable, I am catching everything. The first catch will be chosen. If I first catch throwable and then catch number format exception, it does not make sense because number format exception is a subtype of throwable, as throwable is the top of the hierarchy. It means that this catch will always catch all exceptions and the second catch will never work because it's placed in the next position. In this case, caught displays because throwable catches all the exceptions. However, if I reverse the order, when number format exception happens, caught number format exception displays, and if I choose arithmetic exception, caught displays. You also have this variable in the catch function that you can name whatever you want. It is typically E, but it can be any other name, like error or exception or number format exception. This is a reference to the exception, and you can use that to print this exception. You can also use it to learn something about this exception, read a message of this exception, or some other characteristics of this exception. It can, for example, display where this exception has happened. Let's say you want to do something new in your garden. You know you want a plant, but you're not sure which plant. You need a plant pot to hold it in when you eventually get it. So, in essence, your plant does not exist, but you have the space for it. Your plant is null. To specify a variable without a value, I use the null object to fill the space. In this video, you will learn what nullable types are and how to construct them. You will also learn why nullable types cannot be used explicitly. Now, let's explore how this concept is implemented, beginning with storing a username. Let's say you have an application and you want to let users fill in their name. You decide to keep the name in a variable called name. Usernames will be string type, like Alex, for example. However, what value should be used before a user specifies a name? In other words, what placeholder should be used when there's no value specified? The standard answer to that question in programming is null. Null is a value that indicates a lack of value. So if you want to say that there is no string value here, you should use null. But in Kotlin, you can't just use null anywhere you want. You have to make a type nullable. What that means is you need to make a type that allows a nullable value. And to do that, you add a question mark after the type. String question mark is a special type that indicates that the value can either be null or a string. Both of these values are accepted by string question mark, whereas a regular string only accepts a string. The same with all the other types. If you want to have an integer that is nullable, you need to add a question mark after int. And if you want a character that is nullable, then you need to add a question mark after char. The same with class types. Say you have a class name user and it has a name value. It cannot be null by default. You have to make it nullable to allow null values. Nullable types can also be used as parameters or result types. If you have a function that expects a user, such a function won't accept a null. But if you make its parameters nullable, then null will be accepted. And it works in a similar way with the result type. You can specify a nullable result type, and then your result can be null. And so here, I can return null. I can also make a class parameter nullable to make it possible for the user to have null instead of a name. By default, when you create a user, you can't use null. However, if you use a nullable type here, then the user can have null instead of a name, thus indicating that the user doesn't have a specified name. As demonstrated, nullable types can be used everywhere, but they must be used explicitly. You need to explicitly say that a particular type is nullable, so it accepts null value, and you can do that by adding a question mark after the type to make it nullable. It's very convenient that Kotlin clearly specifies what can and what cannot be null. In this video, you learned about nullable types and how to construct them. You also learned why nullable types cannot be used explicitly. Excellent work. You're making great progress. When using nullable values, as in this example where I have a nullable parameter, I cannot use it like I use a regular value, as such values can be null, meaning I could get a no value or null in my parameter. This means that when I have a user, I cannot just ask for the user's name or call a method on this value. This would work fine if the user is not nullable. However, if the user is null, the null value does not have a name property or a cheer method. So, if user is nullable, I cannot explicitly call the name property or the cheer method on such an object, because if there is null, it would lead to an exception, as this property and method do not exist. So, what can I do to solve this? There are a few ways in which I can deal with nullability in Kotlin. In this video, I will briefly review all of the options. The first option is called safe call. It is written as a question mark and then a dot, instead of just a regular dot that is typically used before a property or function call. Safe call means that I can call the right side if the left side is not null. In this case, the user is not null, so we'll ask its name and print Jake here. I will call the cheer function and print, "Hello, my name is Jake." However, when the user is null, then instead of asking for the name, this expression will return null. So I'll print null, and the cheer method will never be executed because the user is null. Displayed here is Jake. "Hello, my name is Jake," and only the null value printed in here. Another option is called the not null assertion. Here I use 2 exclamation marks after a nullable value. The not null assertion is an unsafe option as it throws an exception when a value is null. So when I pass a regular user or ask for a name, the username displays. When I ask to call cheer, you will call the cheer function on the user. I then call the function with null. Once I call user exclamation mark, there is an exception that breaks the program. That is the reason this not null assertion is considered an unsafe option. It breaks the program by throwing an exception when its left side is null, and that is why this option is generally avoided. We prefer to use safer options. I only use a not null assertion when I am absolutely certain that a value cannot be null. Another popular option is called smart casting. It allows treating a variable as not null after I check that it is not null. For example, if the user is not null, I print the username and I call cheer. The user has now changed its type from a nullable user type into a regular user type. Why has this happened? The reason is that if this property is null, this body was not executed. Kotlin is smart enough to know that within the scope of this body, the user cannot be null. It only works in the scope of this body. You cannot use the user explicitly. Kotlin automatically changes the type of your user when it knows something more specific about it. There are different situations where smart casting works. So if I have code where I return when the user is null, it should achieve the same result. If user is null, you return. So after you pass such a check, user can be considered not null. This means that the user can be treated as not null. In both these cases, when I pass Jake, "Hello, my name is Jake," displays, and when you pass null, there is nothing. You can also do something different. So, right now when you pass a user and this else branch is called, then user is not nullable. So I can ask for its name directly. And if user is null, this branch is chosen, so the user is null. The final option I want to discuss is called the else operator. This operator is called the else operator as it looks similar to Elvis Presley's hair. The else operator is used to provide a default value when a value could be null. When a user is null, I could use an alternative value that can be a user with a default name. A user with a default is of type user. It is not nullable because if the user is not null, then its value is used. But when a user is null, then the right side is used, which is also a user. Either way, there will be a user. These are the most basic ways in which nullability is handled. You will learn more about nullability at a later stage. Until now, you should have learned to use variables to keep individual values like strings or integers. This is useful, but not always enough when coding in Kotlin. Let's say you implement an online shop. You don't know in advance how many products you will offer, and these offers may also change over time. Keeping these offers in multiple variables will be inconvenient. This means that you need an object that represents a collection of elements. Such an object is called a collection. In this video, you will learn more about the need for collections in programming. Collections are a very important part of programming, as nearly all projects require a variety of collections when coding. When you write code to create an online shop, you need a collection of products, a collection of sellers, a collection of buyers, and a collection of different product variants. You may also have a collection of supported payment methods and a collection of supported delivery methods. In Kotlin, there are a few collection types you can use. These are discussed later in the course, but for now, let's explore how collections work in general, and as an example, a list is used, which is one of the most common collection types in Kotlin. A standard way to create a list in Kotlin is using the list_of function and then specifying the values of this list using arguments. Here, I will use a list with 3 values called tomatoes, spaghetti, and chicken. Lists can be transformed into a string either when you just print a list or when you transform a list into a string using a string template. In the first case, it should result in all the elements in the box brackets. In the second case, the list is also displays with all the elements in box brackets. You can also iterate over list elements as well as over all kinds of collections. Using the for loop, if you use a list on the right side of a for loop, you will iterate over all the elements, so you will invoke the body of this for loop for each element in the list. So here, you'll first print tomatoes, then spaghetti, and then chicken. If you need to know how many elements there are on the list, you can use size property. Size property displays how many elements there are in the list. This list has 3 elements, so it will return 3. Finally, if you want to modify a list, the list is read-only, which means that this list object cannot change internally. But you can always create a new list with or without some elements. The easiest way to do this is to use a plus or minus sign. So, if you have a list of strings and you remove an element, as a result, you will have a list without this particular element, which in this case is a list with only tomatoes and spaghetti. And if you use a plus element, you will add this element to the list. So, as a result, you should have a list with tomatoes, spaghetti, and tofu. This creates a new list and it does not modify the previous one. This means that the previous list should still have tomatoes, spaghetti, and chicken. You should now be more familiar with the functionalities common to Kotlin collection types. Good job! Kotlin provides you with many ways to store information. Deciding on what information and how it is to be used is dependent on the project being developed. For instance, if you wanted to store the inventory for your online shop, you could store the product and the price in a list. This will allow you to add or remove products. If the shop has a set number of products that will not change, you could store them in a list, as once a list is written, the number of things in that list are set. In the next couple of minutes, you will learn the difference between list, set, and map. You will also be able to identify which collection type to use. And you will learn that Kotlin collections are read-only and they have mutable variants. There are three main types of collections in Kotlin: list, set, map. Let's discuss them one by one. List is the most basic type of collection and represents an ordered list of elements. A useful feature of list is that you can use the same values in elements multiple times. You may wonder why lists are used in Kotlin programming. You may use a list, for example, to represent products in an online shopping cart or for delivery method options. The order of elements in such a list is preserved, which means that if you define your list of delivery methods in a configuration, these elements will display in the same order on the online payment window. Now, let's explore set as a collection type. Set represents an unordered list of elements without duplicates. The good news is that you can typically find elements in a set faster than finding them in a list. So, when would you use sets? Sets are used when you don't want to preserve the order of the list. They also do not accept duplicates of values. Let's say, for example, that you wanted to store a list of dog names. The order that they are saved in does not matter, but you do not want the same name duplicated. A map, on the other hand, is different from a list or a set. The reason being that it does not keep a collection of elements, but a collection of key value pairs. Keys are unique, and each of these keys maps is exactly one value. These values can be duplicates. Maps are also useful for storing logical connections between objects, like an employee's ID number, which is unique and makes a perfect key, and their position as the value the key maps to. Now that you have learned about lists, sets, and maps, let's explore collections whose structure is read-only and cannot be changed, otherwise known as immutable, but the elements or values contained within them are read and write, otherwise known as mutable, which means they can be changed. Over the next couple of minutes, let's explore the difference between a list and a mutable list. Collections in Kotlin are read-only by default, which means that there is no direct mechanism to change the content that is inside a list. However, you can always make a copy with some additional values. In the parentheses, there is a list with A and B, and this list will not change. However, I can create a copy of this list with an additional element C. This is similar to a string that also cannot change internally. However, I can create a copy with additional elements, so a new str is ABC. Just because a list cannot change internally does not mean that the variable cannot change. If I make this variable var, then I can assign to this variable a copy of the previous list with an additional element. As a result, the variable list will point to a new list with elements A, B, and C. The same is true for a string. If you make str a var, you can assign str plus c into a variable str, and as a result, you will have a string abc under variable str. In both cases, you can replace this with plus equals operator, which is just variable equals to variable plus value. You can also create a mutable list using the mutable list of function. So let's make a mutable list with A and B. This object can change internally as it has functions like add that can be used to add a new element. So here the list changes. Even though the variable is of type val, I can change this list internally because the object mutates inside. It is similar to a bank account class that changed when I deposit or withdraw money using methods. You will learn more about collections later in this course. Now, let's discuss the hierarchy of interfaces representing collections. The collections graph represents the relationship between the most important interfaces. Let's explore the key points of the collections graph in greater detail. Most collections implement an iterable and a collection interface. Iterable represents an object you can iterate over. The most common way of doing this is with a for loop. Map does not implement iterable, so we have no object to help us, but you can also iterate over it using a standard loop. The interfaces representing mutable collections are subtypes of the interfaces representing the readable ones. Mutable list, for example, is a sub-interface of list. This means that everything you can do with a list, you can do with a mutable list, but not the other way around. Interfaces can all be implemented by different classes. Let's explore an example. The default class used as a list is ArrayList, but you can also use LinkedList. The difference lies in the performance of their operations. ArrayList is great for finding an element in a position, where linked list is great to use if you need to add or remove elements. As collections are represented as interfaces, there are a number of different kinds of lists, maps, and sets that you have access to. You should now be able to explain the difference between list, set, and map, and be able to identify which collection type to use. You should furthermore be able to identify which Kotlin collections are read-only and whether they have mutable variants. Congratulations on building another important Kotlin skill. You've reached the end of this module on advanced classes and objects in Kotlin. Great work! You may remember that we started with what data classes, enum classes, and exceptions in Kotlin are. You also learned about the different types of exceptions that exist within Kotlin. You now should also know what nullability is and how to use nullable values. You also learned that if a user, for example, is nullable, you cannot explicitly call the name property or the cheer method on such an object, as it will cause an exception. Next, you explored collections, and you learned that you need an object that represents a collection of elements, and that this object is called a collection. Finally, you learned that there are three main types of collections in Kotlin: list, set, map. You discovered how to use them and also what read-only collections are. It's now time to recap the key lessons you learned and the skills that you gained. With that in mind, let's summarize the key points you learned in this module. During this lesson on special kinds of classes in Kotlin, you learned how to define the special classes available in Kotlin to obtain a specific type of functionality. Identify and explain that data classes are a special kind of class dedicated to serve as a holder of data and help to compare, display, read, and modify data more easily. Explain that enum classes is a special kind of class that represents a set of possible values and that it's defined first by the enum modifier case. And identify and explain the different exceptions that can exist in Kotlin. You also learn that an exception is an unwanted event that breaks the standard flow of your program. The next lesson that you encountered was all about nullability and how to use nullable values. Now that you've completed nullability in Kotlin, you are now able to explain what nullability is. You also learn that null is a value that indicates a lack of value and describes how to use nullable values. You also explored how to solve exceptions when using nullable values in Kotlin. Following your completion of the nullability lesson, you then moved on to an introductory lesson on collections. You discovered programming that needs an object that represents a collection of elements, and that this object is called a collection. During this lesson on collections, you learned how to explain what collections are and explore how collections work in general, but you also focused on how a list is used. List being one of the most common collection types in Kotlin, and explain the various collection types, when to use them, as well as explore the difference between list, set, and map. You also learn that Kotlin collections are read-only, and they have mutable variants. You're now familiar with advanced classes and objects in Kotlin, along with concepts like data and enum classes, as well as exceptions that can happen when coding. You also explored nullability and were introduced to various collection types and how they are used in Kotlin. Excellent! You've made great progress in your Kotlin programming journey. In this course, you covered the essentials of programming in Kotlin. Let's take a few moments to briefly recap what you learned. In the opening module, you had an introduction to the course and explored possible career roles that you might want to follow as a Kotlin developer. You also reviewed some tips on how to take this course successfully and discussed what it is that you hope to learn. You then covered concepts such as variables, values, and types, using numbers and text, conditions and loops, and you began the coding part of your learning. You also completed several exercises in which you learned how to utilize these different concepts in your programming projects. You should now be able to explain what variables, values and their different types, such as strings, booleans, doubles, and integers are. You explored if and if-else conditional statements as well as when conditional statements. These statements helped you set conditions for the way content appeared. You also discovered that loops allow for the execution of one or more statements until a condition is met. In Module 2, you may remember that you learned what functions in Kotlin are. You learned that a function processes data and then returns a result. Next, you explored classes and objects, and you learned that in Kotlin, every value is an object. And lastly, you discovered more about interfaces and inheritance in Kotlin. Then, in Module 3, you learned about Kotlin advanced classes and objects, including special kinds of classes, nullability, and collections. You discovered that there are special classes that you can use to obtain a specific type of functionality. They are enum classes, exception classes, sealed classes, and annotation classes. You also explored nullable types and how to construct them. And you discovered why nullable types cannot be used explicitly. You then explored the 3 main types of collections in Kotlin, which are list, set, and map, and you should now be able to explain the difference between them. You should now be able to explain the need for collections in programming. You should also now know that there are various collection types that you can use in any given situation. You may also remember that Kotlin collections are read-only and that they have mutable variants. Well done on completing this recap. Now it's time to try out what you've learned in the graded assessment. Good luck! Congratulations on reaching the end of this course. You've worked hard to get here and developed a lot of new skills during the course. You're off to a great start with your programming learning, and you should now have a thorough understanding of programming in Kotlin. The key skills measured in the graded assessment revealed your ability to demonstrate knowledge of what variables, values, types, conditions, and loops are, explain what functions, classes, objects, interfaces, and inheritance in Kotlin are, and exhibit knowledge of advanced classes and objects such as data and enum classes, recognize and solve exceptions, and use nullables when required. So, what are the next steps? Well, this course has given you an initial introduction to several key areas. You probably realize that there's still more for you to learn. So, if you found this course helpful and want to discover more, then why not register for another? You'll continue to develop your skill set during each of the Android developer courses. Whether you're just starting out as a programming professional, a student, or a business user, the course and projects prove your knowledge of the value and capabilities of Android. And once you've completed all the courses in this program, you'll receive a certification in Android development. The certification can also be used as a progression to other role-based certifications. Depending on your goal, you may choose to go deep with advanced role-based certifications or take other fundamental courses once you earn this certification. These certifications provide globally recognized and industry-endorsed evidence of your technical skills. Thank you. It's been a pleasure to embark on this journey of discovery with you. Best of luck in the future.